This weekend will unleash a storm unlike anything we have seen this winter season. While the East Coast continues to dig out from Winter Storm Fern, meteorologists are tracking the rapid development of what could become one of the most dangerous bomb cyclones to impact the Eastern Seaboard in years. This is not just another winter storm following in the wake of the previous system. This is a meteorological phenomenon that has the potential to bring life-threatening conditions to millions of people from the Carolinas to New England within the next 72 hours. The atmospheric setup developing for this weekend represents a perfect storm of conditions that meteorologists recognize as the recipe for explosive storm intensification. The combination of extreme cold air already locked in place across the eastern United States, abnormally warm ocean temperatures along the Atlantic coast, and a powerful upper-level disturbance moving through the jet stream creates the ideal environment for what scientists call bombogenesis. Understanding what makes this weekend as threat so particularly dangerous requires examining the process of bombogenesis itself and the unique atmospheric conditions that are coming together to create this potentially catastrophic situation. This phenomenon occurs when a storm system's central atmospheric pressure drops by at least 24 millibars within a 24-hour period. But the current forecast models are suggesting something far more extreme for this weekend's developing system. The meteorological data emerging from the latest model runs indicates this weekend, storm could experience a pressure drop of nearly 40 millibars in a single day, transforming from a relatively weak disturbance with a central pressure around 1,008 millibars into a powerhouse storm system with a central pressure near 970 millibars. This level of rapid intensification places the developing system in the same category as some of the most powerful hurricanes, but occurring during winter conditions when the impacts can be even more devastating. The physics behind this extreme intensification involves the interaction between multiple atmospheric layers and the massive temperature contrasts that exist across the region following Winter Storm Fern. The upper-level jet stream pattern shows a pronounced trough moving through the eastern United States, providing strong divergence aloft that enhances the upward motion necessary for rapid storm development. At the surface, the sharp boundary between the Arctic air mass and the warm Gulf Stream waters creates an extremely unstable environment that feeds energy directly into the developing storm system. The storm's development timeline is becoming increasingly clear as we analyze the latest data from multiple global forecast models, including the European Center for Medium Range Weather Forecasts model, the American Global Forecast System, and the Canadian Meteorological Center model. All three major global models are showing remarkable agreement on the storm's basic development pattern, though subtle differences in timing and track continue to create uncertainty about specific local impacts. By Friday evening, a weak area of low pressure will begin to organize off the coast of the Carolinas, drawing moisture from the warm waters of the Gulf Stream while tapping into the massive reservoir of Arctic air that has been dominating the eastern United States following Winter Storm Fern. This initial development phase is critical because it sets the stage for everything that follows, as the storm's eventual track and intensity depend heavily on how quickly and where this initial organization occurs. The warm waters of the Gulf Stream play a crucial role in this development process, as sea surface temperatures running 10 to 15 degrees above normal for this time of year provide an abundant source of energy for the developing storm system. When this warm, moist air encounters the frigid continental air mass, it creates powerful convection that drives the rapid intensification process characteristic of bomb cyclones. Friday night into Saturday morning represents the most critical period for storm development, as multiple atmospheric processes converge to create conditions that strongly favor explosive intensification. The jet stream configuration shows a deep trough approaching from the west, providing powerful upper-level divergence that acts like a vacuum, pulling air upward from the surface low-pressure system and accelerating its development. Saturday morning marks the beginning of the storm's rapid intensification phase, as the developing low-pressure system encounters the sharp temperature contrast between the frigid continental air mass and the relatively warm Atlantic Ocean. This temperature gradient acts like fuel for the developing storm, providing the energy necessary for explosive deepening that defines bomb cyclone formation. By Saturday afternoon, forecast models indicate the storm's central pressure could drop from approximately 1,008 millibars to near 970 millibars, a rate of intensification that rivals some of the most powerful hurricanes. This rapid strengthening will generate winds that could exceed 60 miles per hour across broad areas, creating blizzard conditions and making travel virtually impossible across much of the storm's path. The geographic scope of this weekend's bomb cyclone threat extends from eastern North Carolina northward through the mid-Atlantic states and into New England, encompassing major metropolitan areas that are home to more than 50 million people. The population density within the potential impact zone creates particularly complex challenges for emergency management and evacuation planning, as the compressed timeline for storm development limits the window for protective actions. Major cities within the potential impact zone include Raleigh and Charlotte in North Carolina, Norfolk and Richmond in Virginia, Washington, D.C., Baltimore, Philadelphia, New York City, Hartford, Providence, and Boston. Each of these metropolitan areas faces unique vulnerabilities based on their geographic location, infrastructure condition, and recent impacts from Winter Storm Fern. Forecast models are currently showing two primary scenarios for the storm's track, each presenting different but equally concerning implications for the affected regions. The first scenario, which shows higher probability in the latest ensemble model runs, places the storm's track closer to the coastline, bringing heavy snow, dangerous winds, and coastal flooding to areas from Virginia Beach northward through Boston. This track would put major cities like Washington, Philadelphia, New York, and Boston directly in the storm's most intense zone, potentially creating the most widespread impacts. In this closer-to-shore scenario, snow accumulations of 12 to 24 inches are possible across much of the Interstate 95 corridor, with locally higher amounts in areas of enhanced lift and moisture convergence. The storm's proximity to the coast would also maximize the fetch over warm ocean waters, leading to higher precipitation rates and more efficient snow production. Wind speeds in this scenario could reach 60 to 80 miles per hour across broad areas, creating blizzard conditions that would make travel impossible and potentially cause catastrophic infrastructure damage. The coastal impacts in this scenario would be particularly severe, as the storm's intense circulation would generate massive waves and significant storm surge along the entire eastern seaboard. Areas of the Outer Banks, Delmarva Peninsula, Jersey Shore, Long Island, Cape Cod, and the Maine coast would experience hurricane-force winds and dangerous coastal flooding that could persist for multiple tide cycles. The second scenario shows the bomb cyclone tracking farther offshore, approximately 100 to 200 miles east of the first track, which would reduce snow accumulations for inland areas but create extremely hazardous conditions along the immediate coastline. This track would still produce significant impacts, but would shift the heaviest snow and strongest winds toward coastal areas and offshore waters, potentially sparing major inland population centers from the worst conditions. In the offshore scenario, cities like Washington, Philadelphia, and New York might receive 6 to 12 inches of snow, rather than the potentially catastrophic amounts suggested by the closer track. However, coastal areas would still experience dangerous conditions, with the added complexity of the storm's most intense winds occurring over open water, where they could generate exceptional wave heights and storm surge. The difference between these two scenarios represents only 1 to 200 miles in the storm's ultimate track, but the implications for public safety and infrastructure impacts are enormous. Current ensemble forecasting data suggests slightly higher probability for the closer-to-shore track, which would maximize impacts across the heavily populated Interstate 95 corridor from Richmond to Boston. Regardless of which specific track the storm ultimately follows, several impacts are becoming increasingly certain as the weekend approaches. Coastal flooding represents one of the most immediate threats, as the bomb cyclone will generate massive waves and storm surge along the entire eastern seaboard. Areas that experienced coastal flooding during previous nor'easters will be particularly vulnerable to significant impacts. The wind threat associated with this bomb cyclone cannot be overstated, as the rapid pressure drop will create extremely tight pressure gradients that translate directly into dangerous wind speeds across broad geographic areas. Sustained winds of 40 to 60 miles per hour are likely across the primary impact zone, with gusts potentially exceeding 80 miles per hour near the storm's center and along exposed coastal areas where the fetch over water maximizes wind acceleration. These wind speeds pose significant threats to power infrastructure that may still be compromised from Winter Storm Fern. Utility companies across the potential impact zone are positioning crews and equipment for what could be another widespread power outage event, potentially affecting millions of customers who may have recently had their electricity restored from the previous storm. Snowfall forecasts for this weekend as bomb cyclone present additional challenges for communities still dealing with snow removal from Winter Storm Fern, as many areas are already operating with reduced snow storage capacity and strained removal equipment. Areas that could see 6 to 12 inches of additional snow accumulation include much of eastern North Carolina, southeastern Virginia, the Delmarva Peninsula, and southern New Jersey, creating significant challenges for transportation systems and emergency response capabilities. However, the most concerning snow accumulation forecasts are reserved for areas closer to the storm's track, where the combination of enhanced moisture transport, strong lift, and prolonged duration could produce 18 to 24 inches of snow. Higher elevation areas of the Appalachian Mountains could receive even higher amounts as orographic lift enhances precipitation rates. The timing of this storm creates particularly dangerous conditions for travel and emergency response operations. The most intense period of the bomb cyclone is forecast to occur during Saturday night and Sunday, when visibility will be severely reduced and winds will create life-threatening conditions for anyone caught outside. Emergency officials are urging residents across the potential impact zone to complete all preparations by Friday evening. One of the most concerning aspects of this weekend's bomb cyclone is how it will interact with the existing snowpack and infrastructure damage from Winter Storm Fern. Many areas are still dealing with tree damage, compromised power lines, and overwhelming amounts of snow from the previous event. Additional heavy snow and high winds could cause catastrophic failures of systems already operating at reduced capacity. The meteorological pattern supporting this bomb cyclone development shows remarkable similarity to some of the most significant East Coast storms in recent history. The combination of a strongly negative Arctic oscillation, a displaced polar vortex, and anomalously warm sea surface temperatures along the Gulf Stream creates conditions that have historically produced the most impactful winter storms along the Eastern Seaboard. Historical analysis of similar atmospheric setups suggests that storms developing under these conditions often exceed initial intensity forecasts, as the rapid intensification process can continue for longer periods than models initially predict. This tendency toward overperformance in rapidly intensifying systems adds another layer of concern for this weekend, as a developing threat. The broader implications of this bomb cyclone extend beyond the immediate weather impacts, as the storm will help reinforce the Arctic air mass that has been dominating the eastern United States since Winter Storm Fern. The storm's circulation will draw additional cold air southward from Canada, potentially extending the period of below normal temperatures well into February. Long-range forecast models suggest that the atmospheric pattern supporting repeated storm development will persist through at least the first half of February, creating potential for additional significant winter weather events affecting similar geographic areas. This persistent pattern represents a departure from typical winter weather behavior and suggests the need for sustained vigilance. Emergency management officials across the potential impact zone are implementing lessons learned from Winter Storm Fern while preparing for what could be an even more challenging event. The compressed timeline between major storms has strained resources and highlighted vulnerabilities in systems designed for more typical winter weather patterns. The economic implications of back-to-back major winter storms are creating concerns across multiple sectors, from transportation and logistics to energy production and consumer spending. Many businesses that lost significant revenue during Winter Storm Fern could face additional losses if this weekend's bomb cyclone produces widespread impacts. Aviation systems that are still recovering from the massive disruptions caused by Winter Storm Fern face the prospect of another major operational challenge. Many airports along the East Coast are still working through passenger and aircraft backlogs from the previous storm, and another significant weather event could create cascading delays that persist for weeks. The human element of this developing crisis cannot be overlooked, as millions of people who just endured one of the most significant winter storms in recent memory are now facing the prospect of another, potentially more dangerous event. Mental health professionals and social services agencies are expressing concerns about the cumulative stress of repeated major weather emergencies. But perhaps most concerning is how this weekend's bomb cyclone threat demonstrates the new reality of winter weather patterns in an era of climate change and atmospheric disruption. The frequency and intensity of rapidly intensifying winter storms along the East Coast has increased significantly in recent years, with bomb cyclones now occurring more regularly and achieving greater intensity than historical norms would suggest. This trend reflects complex interactions between changing Arctic conditions, ocean temperature patterns, and jet stream behavior that are reshaping winter weather across North America. Scientific research into bomb cyclone formation has revealed that these storms are becoming more common and more intense as the temperature contrast between Arctic and oceanic air masses becomes more pronounced. The same atmospheric conditions that produced Winter Storm Fern continue to support the development of additional significant weather systems, creating a pattern of repeated major events rather than isolated occurrences. Current atmospheric analysis indicates that the pattern supporting bomb cyclone development will remain favorable through at least the first week of February, suggesting that this weekend's storm may not be the final major weather event of this sequence. The persistent negative Arctic oscillation pattern that has been driving these extreme weather events shows little sign of returning to more typical winter conditions. The technological capabilities that allow meteorologists to predict bomb cyclone formation have improved dramatically in recent years, providing several days of advance warning for these dangerous phenomena. However, the precision required to accurately forecast exact storm tracks and intensity remains challenging, particularly for rapidly evolving systems that can change dramatically over short time periods. Residents across the potential impact zone are urged to treat this weekend's bomb cyclone threat with the same seriousness as a major hurricane, as the impacts from blizzard conditions, dangerous winds, and coastal flooding can be equally devastating. The rapid intensification process means that conditions can deteriorate much more quickly than typical winter storms, leaving little time for last-minute preparations once the storm begins. The next 48 hours will be critical for finalizing preparations and monitoring forecast updates as meteorologists continue to refine predictions for this weekend as bomb cyclone. While uncertainty remains about exact tracks and intensity, the potential for significant impacts across the Eastern Seaboard is becoming increasingly clear as the atmospheric ingredients for explosive storm development continue to align. This weekend, this bomb cyclone represents much more than just another major winter weather event following Winter Storm Fern. It represents a crucial test of our collective ability to respond to repeated, extreme weather events that are becoming our new normal rather than exceptional events.